Okay, Jude, we're going to go through lesson 31. It's about sets. This is page 5. And we're going to work problems 3A, B, and C. So, really quick, these are the symbols that were identified in this lesson. Subset of is this symbol here. Element of is like a funny looking E. Not an element of is a funny looking E with a line through it. Intersection is an upside down U. A union is a U. Null set is this zero with a line through it, and a complement is the name of the set with the tick on top of prime on it. So let's take a look at sets really quick so we know what we're talking about. So let's say I had a set A. And let's say I had 1, 2, and 3. Okay, so I would write that as A is equal to the set 1, 2, and 3. And I can say 1 is an element of A because I see 1 is in there. I can also write 7 is not an element of A. So this is all what I was talking to you about, nomenclature. When you're talking about a set, you put the little braces around it, and that identifies the set, and we assign this set a name of A. So A is equal to the set of 1, 2, and 3. And all I'm doing here is using that same nomenclature to tell you what is part of A. Like 1 is an element of A because 1 is in A. And that's a symbol that we use there, that funny looking E. Now if I said 7, is 7 in this list? No, it's not. So I can say 7 is not an element of A using that symbol. Okay, so that's the basics of that part of the nomenclature. Now let's go a little bit further, and let's say I had B. And this is B, and I'm just going to put a 4 in there. So now I have A and B, and if I want to write B, I could say B is equal to 1, 2, well actually it's equal to 3 and 4. And we can do the same thing that we did over here. We can say 3 is an element of B, and we can see that here. And we can also say 1 is not an element of B because we can see here B has 3 and 4 in it, and it doesn't have 1. 1 belongs to A. Now, there are a lot of things that you can talk about when you're talking about these two sets. Now, let's say I want to know what are the elements if I combine A and B. So if I combine A and B, you're going to see it's 1, 2, 3, and 4. So I have 4 elements. So I know it's going to be 1, 2, 3, and 4. So how would I write that? Well, if you look at this, I've got 1, 2, 3 here and 3 and 4 here. What did I do? I ended up combining the two sets, and that's called a union. A union is when you combine all the elements between the sets that you're talking about. So I would write this as A union B is equal to 1, 2, 3, 4. Okay, so A union B means I just combine the elements in A with the elements of B. Okay, so that makes sense. So when we do the union, it's gonna look like I combined all of those, and I'm gonna highlight that in yellow. So all this is a union. Okay, so now let's talk about intersection. What does an intersection mean? So I'm going to draw A again, and I've got 1, 2, 3, and I'm going to draw B again. Okay, so now let's say I have a set, and I just want to identify it as 3. Okay. So what is that set that only has the element 3 referred to? If we look at our diagram here, what can you see? Well, we see A is made up of 1, 2, and 3. B is made up of 3 and 4. So when you're looking at this, we're looking at what is in both A and B. So we want something, the elements in A and B. So I'll write that down. Intersection is elements in A and B. In this case, you could have intersection between a lot of different sets, but in this case, we're just going to do 2. So how would we write that? Elements in A and B would be 3. That's this. And the way you'd write that is A intersection B. And that's how you denote the common elements between the two. So those are the basics of sets. I combine the sets, and you in a union, and also you find the common items here with an intersection. Now let's talk a little bit about null set and complement. Okay. So here is a rule, and it kind of makes sense. If I have a set A here, and I don't put anything in it, how do I write that? Well, I could write it like this. I could just say A is the set of nothing, but that's kind of a funny way to write that. So they write that like this. Because you can write it in either way, but this is the way they like to write it. So nothing or null is an element of A. And if you think about it, null is an element of all sets. Because let's say I put in 1 and 2 in here. So I could say A is equal to the set, well, you got null, it's always a part of it, 1 and 2. But that's always understood. You always have an element of null in any set. So that's how they define null as nothing, when you have an empty set. Now, the other thing that we're talking about is, what is a compliment? And it's not when the people say you're smart or you're handsome or you're nice. Those are compliments, but saying that in math doesn't get you a better grade. So this is what a compliment means with sets. So let's say I have the universal set. This is the set of everything. Everything belongs in there. And let's say I have this set A. So if I was defining A, I would write A is equal to, and I'd list out all of the elements. You know, x1, x2, the x just means whatever. And so that's the way I would define A, but let's say I want to say I want everything except what's in A. So when I'm talking about A, I'm talking about the elements inside this purple circle. But let's say I want to talk about all the elements out here. How do I write that? I could list out all those elements, but there are a lot of different elements. But the way that you do that is you say A prime, which is equal to all elements. I'm just going to call them x's not in A. I guess you would do it something like x, which is just an element ID, right? And where x is not an element of A. That's what A prime is, and that's what A prime is over here. All this is A prime. Everything in with the orange lines in it. So that's how you, that's what these definitions mean. Now let's take a look at your problems. Now that we've gone through it a little bit, let's see what the first problem is. And the first problem is 3A. Okay, I'm going to go ahead and erase that. And we're going to do 3A. And if you look at set theory, it's just a way of writing logical statements without necessarily having to use numbers. So let's take a look. Okay, so 3 says shade the diagram. And this is what we'll do. And then write the union or intersection. Okay, so if I drew A like this, and I had B here, let me get a better color. Let's use the orange. Let's say this is B, and I want to know the set of things that are in A and in B. Okay? So we want the set with A and B. So we want basically it's the elements in A and in B. So let's take a look and see what that looks like. Okay, so what we're looking for are the elements in A and in B. So let's shade that so we can see what we are looking at. So it would be, and I'll highlight it in here, we want all of the elements here. So when we're writing that, we have elements in A and we have elements in B here. So when we're talking about we want the elements, the set of elements that are in A and in B, what does that look like? That looks like we are combining the two sets. And we're combining, that's a union. So the way you would write that is A union B, because you're combining the elements or the things in A with the things in B. Now, okay, so the next one is similar. They want the set, this is going to be B, that was A, this is going to be B, and I'm going to erase here, this. So what they want to know are the set of things that are in A but not in B. Okay, so what they want is the set of things in A. Well, set of things in A are all of this here. This is all of A, and this is all of B. So that what they want to know is the things in A but not in B. So we don't want anything with B in it. So what we're going to have is we're gonna erase the things that we don't want. So I'm going to erase all things in B. So what we want is everything in that purple, in this area right here. Right? So we could write it like this. We could just say it's A, the set A minus A intersection B. Because what was the, so we got A, and we're subtracting the intersection, and what was the intersection? The intersection was this part right here was the intersection. So when we write it, and like I said, this is just nomenclature, this is the way you would write it. I want all of A, and I want to subtract the intersection of the two. There's probably a couple of ways you could write that, but this is one way you could write that. And do you understand that this right here is that? That little sliver right there is represented by A intersection B. And when I say A minus that, that means all of A, which is all of this, minus that little sliver there. So that's the way you could write the answer for problem B. So let's go to C, and let's take a look and see what they're talking about on this one. C is the set of things that are not in A and not in B. Not in A and not in B. Okay, so I'm gonna erase that, and this I'm gonna redraw this so we can see it a little bit better. Okay, so here's our A. Well, first I'm gonna draw the universal set. Universal set means everything. So this is U. Not U, but the letter U. And they call it the universal set. So now, let's take a look at A. So I'm going to say, this right here is our A. And we're going to do B like that. Yeah, I'm going to erase that. Okay. So when we look at this, what do we want to represent? We want to represent the things not in A and not in B. Okay, so let's highlight all the things that aren't in A. Well, this is A, so everything outside of A is all this yellow stuff right here, including the B part. So all of, I'll make our universal set a little bit smaller so it's easier to deal with. So I'm just going to cut it off right there. And now we're looking at all of this. So all of this yellow is the not in A part. Okay. Well, we got that covered. Now let's take a look at all the elements not in B. Well, all the elements not in B is all of this. Okay, so that's not, the yellow is not A, and the red is not B. So what we want is everything that has a hash mark, because it's only the ones that have red and yellow that are both not in A and not in B. So you can see that with the yellow and the red. So if I drew this a little bit differently, it would look kind of like this if I cleaned that up. I'm going to draw the universal set again. Here's A, and I'm going to do B in the same color. A and B. So what it's going to be is everything outside of A and B, which is going to be all of this stuff here. You're going to have everything in there except what's inside A and what's inside B. And the way you would write that is, okay, so what we have here, we're combining A and B, so we can write that as A union B, right? Because I've combined those two, but I want everything outside of A and B, which is the complement. When you talk about a complement, it means everything outside of the sets that you've defined. So we've defined the sets that we're looking for as A union B, which is a combination of the A and B that we see here. And so the complement is all the stuff in the red. And can you see that? A union B is everything inside the A circle and the B circle. And when I say a complement, it's going to be everything outside of the A and the B circle when you combine it. And that is all there is to that one. Now let's take a look at, I guess number 4 has some more information. So I'm going to go ahead and set that guy up. Okay, Jude, this is the same lesson, 31. And this is set on, actually this is on page 6, not 5. And this is number 5. No, it's number 4. And you have two pieces, A and B. Okay, so this is what we have set up, and this is the problem. It's saying, complete the Venn diagram for the following set. So we're going to have A and we're going to have B, all the prime numbers. So if we were going to draw this out, we would go ahead and put everything in there. And we'll do that right now. Let me show you what that's going to look like. Okay, so what I've done is I've drawn out the set, and you can see the set A. I've drawn out with all the elements here, and you'll see all of them are in here, and the common ones between A and B, because this guy is set B, are right in here. So we can look and see what our elements are going to be. And I'm not going to draw them all out because I think you're going to see the gist of it. So when I say A union B, it's going to be everything in A plus everything in B. So I would simply put in all of these elements here, and I'm just going to shortcut it a little bit. Minus 6 dot 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 6, or actually I could write that as X is let me get a better pen, because this guy is pretty much dead. So I'm going to draw it as X, such that X is an element of a number. X is less than or equal to 6, and x is greater than or equal to -6. So that's what this represents. So this is a shorter way of saying it. And B is the primes less than 40 is the way that you would do that. So all I will have to do is if I'm doing a union is I would put in all of the elements that are in A and in B. So this would go, and I'll write it out, -6 ... to 6, comma, and then the rest of the primes going from 7 to 37. So if I want to, I could do 7, 11, 13, 17, 19, 23, 29, 31, and 37. So that would be the union, and you can see how I combined everything that was in A and in B, because that's what union means. Now, something a little bit easier to do is the intersection. So it says what's in A and in B. So when we drew this out, and you can see it right here, we have all the elements. The only numbers that were in A and in B are 2, 3, and 5. And we can see that here. Here's our 2 and a 2, 3, 3, 5, 5. If you look at all of the other numbers, none of the other numbers will overlap. So if I'm looking at intersection B, it's going to be the set 2, 3, and 5. And that is that problem. So let's take a look at number 5. So we'll do that here in the next section here. So, okay, this is still lesson 31. This is on page 6, number 5. Problem number 5. And this one is about a town where they are doing, they have 8,000 people, and 5,400 of those people use EnviroGreen for trash pickup, 4,500 use it EnviroGreen for recycle, and 3,900 use it for both. So the question is, how many people do not use EnviroGreen services? Okay, so let's draw that out. We've got our town. This is our town. In our town, it's 8,000 people, right? And so it includes everybody. So what they want to have here, we have those that do the trash pickup, and then we have those that do recycle, and then we have the ones in the middle that do both. Okay, so what we have here is, we know this number, that's both, and we have recycle and trash. So what we want to find out is, what they want to know is, how many people do not use EnviroGreen services? How many do not use EnviroGreen? Okay, so what are they talking about? They're talking about this area over here. So what we have is, and you can see it right away, right? If we call the trash T and the recycle R, what we want to do is we want everything outside of that. So the way we would write that, if we're writing this in set notation, is we would have, the answer would be T union R and the complement of that. So that's what T union R would be. It'd be this plus that, but everything outside of that. So let's see if we can figure out what that is. So if we do T and R, what do we have? Well, T is equal to 5,400. And we have R, I'll call that T, R, and then this is the intersection. So, what do I call that? The intersection. Okay, so what do we have to do? Well, how many people are in this area here? Well, it's going to be T plus R, but we got this common area right here. What do we call this? We call that the intersection. So what we want to do is we want to subtract that intersection to get that. So in order to get T union R and then the complement, what we're going to end up with is we need to find out this. It's going to be T union R minus the intersection T intersection R, and we're going to take the complement of that. That's what the tick means. Okay, Jude, we're going to go through the last bit right here. Where I left off was where we had T union R minus T intersection R. So we have T union R would be all of this, but we want to subtract the middle part, otherwise we count it twice. So the way we do that is we start plugging in the numbers. I'm going to raise this up so you can see it a little bit better. So you can see our total is going to be 8,000, and we're going to have our value there of U minus the 6,000, and you remember how we got 6,000, right? We got the 6,000 by taking the we took the total T, which is 5,400. We had T equals 5,400. And we added the R. So we add that, and R was 4,500. That gave us 0,099. So I had T and R, I end up with 9,900. But remember, I've got to get rid of the intersection, and that's going to be minus 3,900. And that gives me 0,006. So that's how we got the 6,000. So now we know that the T plus the R, getting rid of the intersection, which is double counted, we end up with 6,000. So the question was, how many people do not use EnviroGreen? Well, we find our total, and what's our total? The total they gave us was 8,000 people. So our total, or the universal set, is 8,000, and they want everything that's not in these two, so we subtract that, and that value is the 6,000 that we have here, and that came from this value right there. That ended up being 6,000, and so we subtract it. So 8,000 minus 6,000 gives me 2,000. So we have 2,000 in here on the outside of the trash and recycle. So that's where we get our total. So the value here is 2,000 people do not use EnviroGreen. And I'm going to ask you, Jude, and I want you to be honest. Do you use EnviroGreen, pick up your trash, and do you recycle? Anyway, that's all we have for today. Love you guys. If you have any problems, make sure you note them, and we'll go through them. So, and keep practicing your square roots by hand. It's good practice, and your skills will get better and better and better. Love you guys.